Hi everyone. So today we are going to be taking a look at domains of linear and quadratic functions as well as square root functions in interval notation. All right, so that's what we're going to be doing today. This is not in any sort of note packet, so you should take out a sheet of paper right now. We're just going to go through these kinds of questions together. And just as a reminder, we know domain is our x values of the function. All right, so let's just get out a sheet of paper and we will get started. So we talked about this last week, that the domain, right, when we're looking for domain, we need to take a look at, well, what can the x values not be? And I see this square root function here, right? So I'm giving you this linear function in a square root. And I see, well, we remember from Algebra 2, okay, if I'm looking at the set of real numbers, right, if I'm looking at, or I'm talking about the set of real numbers, that does not include imaginary numbers. Imaginary numbers are not real. So if I'm talking about real solutions, what can this underneath the square root never be? So we need to consider, can it equal 0? Can it be greater than 0? And can it be less than 0? So let's think. Can what's underneath the square root equal 0? Can this equal 0? Yeah, why not? You can take the square root of 0. It's 0. So that checks out. Can I take the square root of a positive number? Sure. I can take the square root of 2. I can take square root of 1. Square root of 1.5. It doesn't matter what the number is. As long as it's positive, we're good. So these check out. So already I'm looking at greater than or equal to is good. And then let's check out our last case. Can it be less than 0? Can I take the square root of a negative number? And let's say, I don't know, negative 4. No, because now it is imaginary. So we're looking at it being greater than or equal to 0. So let's erase everything else we have here. And we are setting what's underneath the radical greater than or equal to 0. So we have our 8x minus 40 is greater than or equal to 0, right? We're talking about the possible domain, the x values. Okay, so I'm going to get x by itself. We have 8x is greater than or equal to 40. And we'll get x is greater than or equal to 5. So that's the domain for this linear function in the square root. But I want to know what that is like in interval notation. So that's today's lesson. We're including interval notation. So what you guys need to remember, interval notation is things like this. Okay, so if I were to draw a number line, right, I'm just making this up. If I were to draw a number line, let's say we're looking at it going from greater than or equal to 4. Okay, this would read as x is greater than or equal to 4. Well, I want to write this in interval notation. We include 4. That gets the hard bracket. And we're going towards infinity. So this is interval notation. This is set builder notation. This is interval notation. So if we were to now do the example that we were given, right? If I have x is greater than or equal to 5, so here's 4, 5, 6. So if x is greater than or equal to 5, we put the closed circle. Arrow would be shading to the right. We include 5, and we're going towards infinity. So you may want to write down, okay, closed brackets means including, right? We're including the number. Parentheses means not including the number. Okay, you never actually reach that number. Okay, so a closed circle would indicate something that has a hard bracket, and an open circle indicates something with a soft bracket, so those parentheses. Okay, so that's just a little reminder, and I'll include those reminders as we go. So our answer to this question in interval notation, well, we just said x is greater than or equal to 5. That's what this looks like on the number line. So we're going from 5 towards infinity. So this is my answer in interval notation. Okay, let's take a look at another example. So make sure you have this all written down. I'm about to erase this. Okay, so let's take a look at our next example. So now we're talking about linear functions in the square root of the denominator. So we're taking a look at linear functions now in the square root of the denominator. So again, when we're talking about domain, we need to think, well, what are x values that this function can never be? Maybe there are no restrictions. Maybe x could be anything. Okay, but very unlikely now that we have a denominator. The other example, we had no denominator. Okay, so now we're introducing that denominator. So we'll take a look at both the numerator and denominator, and let's see what's going on. Hopefully you guys remember, what can a denominator never equal? A denominator can never go to what? A denominator can never be 0. If your denominator is 0, this is something that's undefined. Okay, so our denominator can never equal 0. So I'm just going to write that down, that this denominator can never equal 0. We know that's true. Okay, let's see. Can this denominator, taking into consideration that there's a square root here, can this denominator be negative? So can it be less than 0? Can this denominator be negative? Well, can I take the square root of a negative number? Could have made that negative 40. It doesn't matter. Can you take the square root of a negative number? No, it's going to be imaginary. This would be imaginary. So can it be less than 0? No. So let's see. Can we be greater than 0? Let's see. Can we be greater than 0? Okay. Well, can this denominator, so this 4x minus 4, can the denominator be bigger than 0? Yeah, you could take the square root of a positive number, right? You could take the square root of 1. You could take the square root of 12. You could take the square root of a positive number. So that checks out. X can be greater than 0. Okay? We know it's not greater than or equal to, because you already told me here it can't equal 0. So there's no equals to piece. Okay? It's only going to be greater than. So we know that we have, let me just rewrite this here. Okay? We know that we're looking at greater than 0. We just kind of checked that box off. We know that we're looking at greater than 0. But now that's just for the denominator. We know this denominator has to be greater than 0. What about the numerator? We didn't even talk about the numerator. Are there any restrictions on this numerator? Can this numerator never equal 0? Can it be bigger than 0? Can it be less than 0? Let's go through all the pieces. Can a numerator equal 0? Can I have 0 over the square root of 4x minus 4? Sure you could. That numerator could equal 0. This whole thing would just become 0. So we can equal 0. So I'm actually going to write we can equal 0, and I'll give it a check. Can I be greater than 0 in the numerator? So could I be positive? Well, let's see. Could I have something like 9 over, again, doesn't matter. We're just plugging in a number, any random number. Okay, this 4x minus 4. Can I have a positive number in the numerator? Sure I could. And again, could I have a negative number in the numerator? Yes, it has no impact on this denominator. They're totally separate. So we know this numerator can be anything. So there are no restrictions on the numerator. So we don't have to check the numerator because there are no restrictions. All three of these things checked off. The reason why we are restricting our denominator here, because we didn't have everything checked off. Okay, if we run through this really quickly again, we said, nope, it can't equal 0, and nope, it can't be negative. We're only looking at greater than 0. So because two of these things didn't check off, yeah, we have to evaluate our domain. So we have 4x minus 4 is going to be greater than 0. Just get an x by itself. And I will get x to be greater than 1. Now again, we want to write this in interval notation, right? Just go back to what we wrote, interval notation. Okay, so interval notation, well, if we were to put this x greater than 1 on a number line, so maybe here's 0, 1, 2. Okay, and we're greater than 1, so open circle. And this arrowhead is pointing to the right, so we're going to shade to the right. And I'm looking at all the values of x that are bigger than 1. So I'm not including 1, so it gets the parenthesis, and I'm going towards infinity. So that is my final answer in interval notation. Alrighty, make sure you have this written down. We're going to take a look at 2 more examples and we are good to go. Alrighty, here is our next question. So now we're taking a look at linear functions being just in the denominator, so no square roots this time. No square roots whatsoever. Okay, so let's see. Are there any restrictions on the numerator? Let's go through our steps. Can this numerator be bigger than 0, less than 0, and equal to 0? If all 3 things check off, we have nothing to worry about with the numerator. So can this numerator here, can this be bigger than 0? Sure can. Could I have a negative numerator? Yeah, what's wrong with having negative numbers in the numerator? That's no issue. Can my numerator go to 0? Yeah, you could have 0 over a an expression that's going to go to 0. So yeah, all 3 things check out. Nothing for us to do about this numerator. We got to check the denominator now. Okay, so nothing to worry about with that numerator. All right, well, let's see the denominator. We got to go through all 3 things. Can this denominator be greater than 0? Yeah, this denominator can be bigger than 0. There's no issues. We can have a positive denominator, no problem. No problem. Can this denominator be negative? Now be careful. There is no square root here. You are not taking a square root. So can this denominator be negative? Yes. You're not taking the square root of anything, guys. If I were to plug in, I'll just give you a number here, for example. Let's plug in x to be, I don't know, 5. So if we let x equal 5, let's see what happens. I have 6 times 5 minus 48. We have 30 minus 48 is negative 18. Yeah, that's no problem. If I were to plug in x to be 5 in this numerator here, I'd have 5 plus 1 over negative 18, which is 6 over negative 18. Sure, that's no problem. There's no issue. So yeah, this denominator can be negative. This denominator absolutely can be negative. So let's give that a check. And can this denominator equal 0? Can our denominator equal 0? No, because then it will be undefined. So we know this denominator of 6x minus 48 cannot equal 0. We know it cannot equal 0. So we're just going to get x by itself. We'll have 6x equals 48. And you'll have x cannot equal 8. So now, if you guys were to think about this on a number line, think about this on a number line. I've got 7, 8, and 9. And x cannot equal 8. So if I can't equal 8, I've got an open circle here. I can't equal 8. But I can be everything else. The only thing I can't be is 8. I could be everything over here. I can be everything over here. But I just can't be 8. So if we analyze this, guys, I'm coming from negative infinity. Going, stop. I stop at 8. So I'm coming from negative infinity. I stop at 8. And from 8, right? So we took a break here. From 8, we're going. Keep going. We're going towards infinity. So we union this with 8 to infinity. This is how we would write this in interval notation. Again, I'll repeat this one more time. We're coming from negative infinity. Stop. You can't equal 8, hence the parenthesis. And then we go from 8 towards positive infinity. Again, you can't equal 8, so we have the open parentheses. You could also never equal infinity, just so you know, if you didn't know that already. You can never equal infinity, hence the open parentheses. All right, last one for the day. We're going to do one more question, so make sure you have this written down. We're doing one more. Alrighty, so hopefully you guys can try this one out on your own. So maybe pause the video here and see if you can give this one a try. But you definitely need to factor the denominator. So definitely factor the denominator. Alright, so I'll give you a few seconds. Maybe pause it and let's see. Okay, so hopefully we've noticed by now there's no restriction on the numerator. This numerator could be positive. It could be negative. It can equal 0. So there are no restrictions on the numerator. but hopefully we'll recognize this denominator can't equal a few things. So let's see. Let's see. Well, first, my first piece of advice for you guys was to factor this. So I'm just going to rewrite. We have 4x minus 1 all over. Again, just doing the math here. This should be x plus 7 and x minus 6. So if we look, again, we need to check. Can we be bigger than 0, less than 0, and equal to 0? There are no restrictions on the denominator in terms of it being positive. This can be positive, no problem. So greater than 0, yep, no problem. There's no square root. Can this be negative? Again, yeah, no problem. There's no square root. Can be negative. Well, for what values of x does this thing make the denominator become undefined? Right? We know this denominator cannot equal 0. We've already established that it can't equal 0. So let's write. We have x plus 7 times x minus 6. We know cannot equal 0. So what are the x values that make it go to 0? T-chart. X can't equal negative 7, and x can't equal 6. So guys, x can be anything but these numbers. X can be anything but these numbers. So make a number line. We have negative 7 and 6. We can't be negative 7 and we can't be 6. But I can be everything here, here, and here. So again, we're going to need to union, right? We're writing this in interval notation, hence the union of sets of numbers. So we're starting all the way over from negative infinity, going, stop at negative 7. So I have negative infinity to negative 7. We don't include negative 7 because of the open circle. And now let's see. We're coming from negative 7, going, stop. So we're going from negative 7 to 6. So we union that with negative 7 to 6. Unioned with again, we're coming from 6, going, keep going towards infinity. So there you guys have it. This is your answer in interval notation. All right, this would have all fit on one line if I had the space. But we're coming from negative infinity to negative 7, unioned with negative 7 to 6, unioned with 6 to infinity. Alrighty, talk to you all soon.